we'll be looking on how to calculate wavelengths in a stationary wave. Now remember, a stationary wave are two equal waves that have same frequency, same amplitude, same wavelength, but opposite in direction. The wave traveled and struck a point, a boundary, and reversed. So that's the stationary wave. And we say such a wave do not transfer energy. It's unlike a progressive wave that is just transferring energy. Now, there are things you have in a stationary wave. What are the points? We have a node, we have an antinode. These are the nodes, while these are the antinode. This is the node, and this is the antinode, and this is the node. Now, what is a node? A node is that point of zero displacement. A node in a stationary wave is that point of zero displacement. So one of the reasons why a stationary wave cannot transfer energy is because of the existence of nodes. So a node is the point of zero displacement, but the antinode is the point of maximum displacement. At this point, look at this wave. This is maximum displacement compared to this point. The wave has traveled. So this is the height it will go to, and it's falling back. So the antinode is the point of maximum displacement, while the node is the point of zero displacement. So a transverse wave that is plucked at a point or stopped at a point at a boundary will give us a stationary wave, and a stationary wave has a node and an antinode. How do we calculate wavelength in such a case? Remember, this point is not identical to this point. Rather, this point is identical to this point. I repeat again, this point is not identical to this point. Although they are node and node, but this point is actually identical to this point. Why? Because in terms of degree, if you take the degree format of it, you realize that this is 0 degrees, this is 180 degrees, while this is 360 degrees. And at this point, this wave is going up. At this point, the wave is going up. At this point, the wave is coming down. But at this point, the wave is actually going up again. So this place is in phase with this place. But this point is not in phase with this point. So a particle here and a particle here, they are not in phase. Why? Because it's not complete. It's not a complete circle. But a particle here and a particle here in a wave is actually in phase. I'm trying to say something like this for more clarity. If this is a wave, a particle here and a particle here are not in phase, but a particle here and a particle here are in phase. A particle here and a particle here, they are not in phase. But if I could continue with this and put a particle here, a particle here and a particle here are in phase. So 1 and 2 are in phase. 3 and 4 are in phase. 3 is not in phase with 5. They are out of phase. Likewise, 1 is not in phase with 6. They are out of phase. You are in phase when there is a complete circle between the two identical points. So this point is identical to this one wavelength. This point is identical to this one wavelength. But here to here is not one wavelength. So here to here is half wavelength. Here to here is half a wavelength. So come back to this diagram. You see that node to node is not a complete circle. Node to node is not a complete circle. Node to node is half a complete circle. So, but node to node is a complete circle. I repeat again, if you look at that diagram over there and consider this diagram over here, you realize that node to node is not a complete circle. It's node to a node that is a complete circle. So in calculating wavelength, we have a node to a node is equals a complete wavelength, which is one wavelength. Actually, what applies to node applies to antinode. So an antinode to an antinode to an antinode is equal to one wavelength. What about a node to a node? So a node to a node, we have, this is how will I put this now? This the successor of this. So between two successive nodes, what you have is equal to half the wavelength. Then antinode to antinode is actually half the wavelength. Then what about a node to an antinode? A node to an antinode. Therefore, a node to an antinode is actually one quarter the wavelength. I'll show it to you here. If here to here is one circle, which is a full wavelength, here to here will be half the wavelength, while here to here will be one quarter the wavelength. I repeat again, here to here is a full wavelength, here to here will be half the wavelength, that's node to node. Then while here to here, node to antinode is lambda over 4, which is one quarter the wavelength. A short way to do it is always go with a lambda node to antinode. So between this point to this point, you ask yourself, how many node to antinode do we have? We have 1, 2, 3, and 4. So between these plates, I have 4 times lambda over 4. This cancels out this, and I have 1 lambda. So it means between 1, 2, 3. Between 3 successive nodes, we have a full wavelength. But between 2 successive crests, we have a complete wavelength. So in my next video, I'll be showing you various questions and how we can calculate wavelength in full using all of these explanations. Thank you. Now, let's look at some questions as regards what we've said so far. Number 1 says, the angle between two successive crests is dash. Now remember, solution. In our last class, I told you about between a crest and a trough and a crest and a crest. So this is a crest and this is a crest. Remember, the distance between here to here is one wavelength, and one wavelength means is a complete circle. And a complete circle, this is 0. A complete circle, this is 180. This is 360. So, but for a complete circle, this starts from 90. Then if you check this point, 90 plus 90 plus 90 plus 90, that will be 360. So between two crests is 360 degrees. That is the answer. Take note, in another question, you might not see 360 degree, but you see 2 pi rad. That's 360 degree. This is equivalent to 360 degree. So it might be giving you in degrees, or it might be given to you in rad. So this is equivalent to this. Now the second question again says, the distance between a successive crest and a trough is dash. Now remember, this is a crest and this is a trough. So the distance between a crest and a trough, remember we said, is 180 degrees. A crest and a trough. And between a crest and a crest is 1 lambda, but between a crest and a trough is half a wavelength. That's half lambda. So if we come to check, quarter wavelength not correct, twice the wavelength not correct, full wavelength no. Full wavelength will be either crest to crest or trough to trough, but the last option says half a wavelength, so it's half a wavelength. That is the answer. Now for the third question, we said 60 complete waves passes a particular point in 4 seconds. There is something here within this first sentence. 60 complete wave passes a particular point in 4 seconds. What this place, this first sentence is trying to show us, a term in wave called frequency. Frequency is equal to number of oscillation over time taken. That's frequency. So if we are having 60 complete waves in 4 seconds, it will now be equal to 60 over 4. And the frequency will now be 1, then that's 15 hertz. So this first sentence has been solved. 60 complete waves passes a particular point in 4 seconds. If the distance between 3 successive troughs of the wave is 15 meters, how can that be solved? It means that if I have a wave of this nature, I will have a wave with 3 successive troughs. So this is a crest, this is a trough, this is a crest, this is a trough, this is a crest, and this is a trough. This is a trough, this is a trough, and this is a trough. So this is an example of 3 successive troughs. Now remember, from this trough to this trough is a wavelength. From this trough again to this trough is another wavelength. So the distance between 2 successive troughs is 1 wavelength, but between 3 successive troughs is 2 wavelengths. So I will say distance, which is L, distance, which is L, is equal to 2 lambda. So the distance between 3 successive troughs is 2 lambda. What about if it was 5 successive troughs? It will be 4 lambda. What about if it was 10 successive troughs? It will be 9 lambda. That's 9 wavelengths. What about if it was 100 successive troughs? It will be 99. It's always a reduction of 1. So back to class. It means that if the distance between 3 successive troughs of the wave is 15 meters, so L becomes 15 is equals 2 lambda. Therefore, lambda equals 15 over 2, which equals 7.5 meters. So I already have my wavelength. Now to solve for the wave speed, the speed of the wave, the relationship between speed, frequency, and wavelength is given as V equals F lambda. So our frequency we got from the first sentence of the question, which is 15, which is now 15 hertz, times our wavelength, which is 7.5. Then our wave speed will now be 112.5 meters per second. So this is a formula that helps or shows a relationship between wave speed, frequency, and wavelength. Remember that the question came in a dicey form, but we have to bring out the frequency first. Then second, we have to use our knowledge of wavelength to solve for the wavelength. Then third, we have to solve for the speed, and that becomes our final answer. Thank you. Now let's look at more questions. The question says, determine the number of wavelengths in this diagram. Determine the number of wavelengths. Now remember, if you look at this wave, it's starting from this point. And so this would have been a crest. While here, so I'll put here a crest. While here is a trough. This point is a crest. While here is a trough. Then this point is a crest. While this point is a trough. Now if you look at this, now remember we said between a crest and a crest is 1 wavelength. Between a crest and a crest is another wavelength. But within a crest and a trough is half a wavelength. So the number of wavelengths we have here is 1 wavelength. That's solution now. We have 1 wavelength plus another wavelength, then plus half a wavelength. So that's 2, 1 over 2, or 2 and half a wavelength. That's the total number of wavelengths in the diagram, or you have it as 2.5 wavelengths. So the wavelength in this diagram is 2.5. Another way you could say it is this to this is half a wavelength. Crest to trough is half a wavelength. Trough to crest is another half a wavelength. Crest to trough is half a wavelength. And that crest to trough to, sorry, another trough to crest is half a wavelength. Another crest to trough is half a wavelength. So how many half a wavelength do we have? We have 1, 2, 3, 4, 5. So I have 5 times half a wavelength. So that becomes 5 over 2 wavelength, which is as 2.5 a wavelength. So those are the two possible ways you can get that done. The next question says, determine the wavelength determine the wavelength if the wave speed along the wire is 120 meters per second. Now, if you look at from this point to this point of the wave is 125 centimeters. If you convert this to meters, it will be 1.25 meters. Why? Because the wave speed was given us in meters, so I'll convert centimeter to meters. Now, what's the next step to solve this? Now, remember, this is a node, this is a node, this is a node, this point is a node, this point is a node, and this point is a node. And we said between a node and a node is lambda over 2, half a wavelength. So we have half here, half here, half here, half here, half here. So how many half do we have? Lambda over 2, lambda over 2, lambda over 2, lambda over 2, lambda over 2. So I have 1, 2, 3, 4, 5. So I have 5 lambda over 2 in this expression. Half, 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 half. 1, 2, 3, 4, 5. So distance, solution for number 2. Solution, I have distance equals 5 lambda. So what is this distance equal to? 1.2. So I have 1.25 is equals 5 lambda. Therefore, what is wavelength? Wavelength is 1.25 over 5. That becomes 0.25. 0.25 meters is our wavelength. But that's not, is that what us? Yeah, so we're looking for the wave speed. So determine the wavelength. If it is so, we have the wavelength. This is what we are looking for. But if the question was to find the frequency, since they gave us the speed, we will now say frequency. Speed is frequency times lambda. So our frequency will now be equal to, what's our speed? Our speed is 120 over what's our lambda is 0.25. So if the question was the frequency, this is what we would have done. But the question is determine the wavelength. So this is what we are looking at. So to get it, this is what it looks like. Thank you very much.